produce it. So I thought we would do something instead, which is robots. So Node, most people use it as a, I don't know, replacement to Rails, do a website. But there's plenty of other things that you can do with Node. You can do command line apps. You can set DNS servers. Please don't. You can do a lot. Like basically, if it's networking glue, Node will be good at it. Something that people started doing is this concept of node bots, which is yet another use for Node.js. So we're going to show a small robot demo called Cat Roulette. Cat Roulette is like an alternative to Chat Roulette. Chat Roulette was a great idea, but was a little nasty because humans got to meet humans, and that, humans, it doesn't work out. So we think like, okay, let's meet cats with humans. That will work, right? If you put a cat in a human, only cuteness comes out of it. So the architecture is the following. We use a library called Johnny5, which basically is like the jQuery of building robots in Node. And that's going to send stuff over a USB connection. Oops, let's plug that in. To the robot. And I'll show the robot in a second. The robot is going to allow you to interact with your cat. Then we have a command line tool. It's built in Node. And that uses WebRockets to talk to a www thing. Basically, it's jQuery. You point and click, and you can move the mouse. So what is the robot that we're talking about? Let's try this thing. So in here, you can see the Arduino board and a breadboard. And basically, are you familiar with the notion of servos? It's just something that allows you to turn like this. So left and right. So there's two. There's the next one, a Y one, and then there's a laser. So this is basically a way for you to remotely control a cat laser via WebSockets, right? So you're going to go like X, Y, turn on laser, turn off laser. Cool? Let's try it out. So we start our static file server, which is also capable of doing WebSockets. We start our cat distraction device. There we go. Brilliant. We have a REPL here if I wanted to do something, which I'm not because I'll probably break something. And we can refresh this page here. And there we go. This should be ready, hopefully. There we go. So we can move this around. Can you guys see it? Just a little bit. Turn on the laser. Hopefully I'm not blinding someone by now. There we go. If you look at the back, you can see the laser going there. It's very dim because it's being powered by USB. But I thought that that was a good idea because I didn't want to blind anyone. Like, this is actually a powerful laser. So, there we go. Let's turn this off and not kill anyone. So cool. So you can use Node to do things that are slightly unconventional. If you're curious, the code, I'll have all my code. It's already on my GitHub, so you can already find it. Please don't. Please look at the talk first. But anyway, it's something very simple. The board just has like inputs for X, inputs for Y, and inputs for the laser. And then you just control it, as I said, via WebSockets. You just say the LED numbers, where are the servos, and then you have something like whenever the client says X, I say the hardware to do X. Whenever the client says Y, I'm like, okay, move the hardware to Y. This is why I said that Johnny5 is like the jQuery of robots, because look at that, it's so simple. Anyway, cool. So we established, everyone knows Node. You can also do different things with Node, but let's get back on topic. You can ask me questions on the end, and if you want to see it or play around with it and understand how it works, the code is all online, so you can see it. So Node. What are the questions that people normally come to me and say? Sometimes they're humble enough to go like, okay, we're ashamed of the code we've written. Most people are afraid of the security flaws that they can't predict because they never run a Node app in production before. After you start with NPM, everyone here is familiar with NPM, I guess? Yes? After people start with NPM, they go like, oh, this is super powerful, this is super nice. Then when they're deploying, they're like, oh, this is super powerful, this is way too nice, right? So how do you protect against that? Normally people they're used to deploying their Java apps, PHP apps, .NET apps, they have their infrastructure. For Node, that changes. So what happens is that developers love Node, they end up seeing Node as grunt or something as such, because they're afraid of putting it in the deploy toolchain. Is it truly web-scale sauce? Is it really going to work? Or are the things on the internet all lies? Like that video that you guys know of, what's it called? Like those MongoDB cartoons that then they did for Node. But most of all, people are afraid of the last question. How can I support this thing in production and avoid disaster, right? I know I don't have the skills yet. How do I measure so that every time I deploy, I'm not setting myself up for failure? Of course, the other questions are also very important. So let's try to debug an app. We're going to just run a very simple chat app, okay? And then we're going to run a load testing against that app. And finally, we're going to inspect the results that come from it. Cool? So we're going to pre-bake this. But first, whenever you're debugging a Node application, this is what I do first. So everyone here familiar with things like New Relic, StrongOps? Everyone used New Relic before? Raise your hands. Not everyone. So New Relic, StrongOps, etc. just give you a very easy way to look at your app. For instance, if it's an HTTP app, you can see for each route how many seconds it took in average, and you can see all the requests, the latency. They even invented a notion of performance score, so you understand the performance of your app. And they are very, very useful when you're first looking at your app and you have no idea. So you're like, okay, I want to deploy this, and you want to identify bottlenecks. Another thing that is really useful is something that Mozilla, Lloyd works at Mozilla, did, which is called node2busy, which kind of mimics how Erlang works. That is, when you get too many requests, instead of starting to trash the process, it goes and slows down and just serves as many requests as it can. Does that make sense? Some very important points is that if you are running at a massive scale, APMs are going to hurt your performance. And when you run your performance tests, if you have the APMs enabled, they will show up. You'll go like, oh, look, that's New Relic, and that will be significant. The reason why most people don't care about it and they use it in production is because they have enough servers, right? And they know that they can handle this much load with these many servers, right? I can say, okay, I can handle 5,000 requests a second per server. I add a lot of servers. This is my peak. It's fine to have New Relic. If you're not in a system like that, then you have to be careful. Either you have a staging environment where you run these tools, so you can have a notion of what's happening to your performance, or the other setup you can do is on your load balancer, you can have one machine with New Relic on. So imagine you have 18 servers. One of them has New Relic or StrongOps. And the measurements are all from that particular machine. You don't see anything from the others. But the traffic is just being routed randomly. So it's probably an accurate sample of what's happening in your app. And it will hurt your performance less. We're not going to set up an APM. They're all, if you ever used any of these systems, you can go to them and .com, click, get started, and in 5 minutes you'll be set up. But that's normally where you should start. And then you should look at things like this. What's my CPU, memory, and disk usage? Normally you do this via script, even though APMs will do this for you too. What code paths are the slowest? Is the event loop blocked? For how long? And why is it blocked? Anyone thinks that having a blocked event loop is a problem here? Do you think it's a problem if the event loop in Node is blocked, like for half a second? Well, if you have your event loop blocked for half a second, that means nothing else is running in Node at that point. So this is normally the contention point for Node. I've seen apps that would block the event loop for as long as 1.5 seconds per request, and these are like serious apps, so they weren't handling very well with that. The way you can leverage that is you can install something like TooBusy, and you can use DTrace to get to the hold of what is the problem. How many requests are you handling? What are the connection pool sizes? Anyone here ever used Mongoose, HTTP, and had to adjust a pool size? Nope? Okay. So if you're in Node, Node can do like all the things, sends it to libuv. But imagine you're running to a database, right? You still need to define what's the amount of concurrent connections you can have to that database, kind of like what's the pool? How many agents do I have that connect to that database? That normally turns out to be one of the most important things in your performance. If you only have like a pool size of 1 to access your MongoDB, that's probably going to be a bottleneck. Things are going to start to like queue up, and that's going to hurt you. So this is normally a place where you want to look for performance issues, and where, when you're running your tests, a place where you can adjust and try to see the differences. The science of this, the engineering of this, is to look at a machine that you have in production, finding a set of tests that you can run against your code, and then every single time, like when you do a change, capture the difference that happened on that machine. Then you know that that specific machine on that specific cloud provider with that specific code can handle these many requests. If your boss says, I need 100,000 requests, you know how many machines you need. Of course, then you have to provision all the machines, etc. But this is one of the most important things. If you see the memory growing in Node, that will probably be unlikely. A memory leak in Node doesn't always show, unless it's in Node core itself. It doesn't normally show as memory. It normally goes to CPU. The reason for that is that V8 is a garbage collected environment. So if the leak is not really, really horrible and really, really obvious, what will happen is V8 will start garbage collecting a lot because you're like creating all these objects. And V8 are like, okay, I can close this. And that normally shows up as CPU usage. The CPU usage goes very, like, because you're branching out so fast, CPU usage increases, and that's what you notice. It's like, okay, the memory seems okay, but the CPU is going like crazy at 100%. That can be something where you're like branching out too much, have too much memory being allocated, and V8 is just doing too much work, garbage collecting. Then finally, you can look at the performance issues, like, is it database latency? One of the last things I did, we found out that it was actually like this PHP service that would take 1.5 seconds to respond every time we would do it. Not because it was PHP, just because it was bad. And yeah, you have to look at that. Just imagine, if you have a pool size of 2, it takes 1.5 seconds each, well, you know what's happening, right? So let's adjust that pool size. Actually, can the server even handle it? Cool. So let's try it out. Let's run an experiment against this server. So I've tried, everyone knows ScienceCat? I've tried to put it in ASCII. It's not brilliant. This is the guy over here, ScienceCat.
Left or the right?
Left. Your left, your right, I don't know. Whatever, I'm dyslexic. Next. So we're going to start by doing a load test. For instance, in this load test, what we're saying is, okay, we're going to test meowhost on port 0xcat. We're going to do this load test. First, we're going to do an arrival stage. arrival phase with a duration of 10 seconds. That's phase 1. And we're going to add 1 user a second. Then we're going to say, these are the use cases for my app, right? You need to be as realistic as possible about the traffic in your app. For instance, let's say I'm Twitter. I might say, well, 60% of my users go directly to a tweet. Actually, that's not true. It's probably 10% of people click a tweet directly. Then maybe, I don't know, 90% of the users get it through the timeline. It comes on the timeline, I see, and then I click it, right? So you have to say something like, create this session with probability of 90%, get the timeline, get the tweet. Create this session with a probability of 10%, goes to the tweet directly, right? And then you can run load tests against something that is meaningful for you. And that's what you should be doing. You shouldn't be just running artificial tests like this one, because it's going to yield crap results. And in this demo, I'm also going to run an artificial test. But mostly because for demo purposes, I didn't want it to tumble over, like create a million concurrent connections and then go like, yeah, that didn't work. My computer is on fire. My cloud provider has banned me for life. And yeah, so you should create things that are meaningful for your application. So let's do it. Let's npm run the experiment. So first, let's go on the wild side and do npm run deploy, which is going to change the code on the server side, which is a horrible idea. We all know that the best deployment tool is rsync, right? No? Right, exactly, it's not. Then we do npm run experiment, if I can type it correctly. There we go. So this is a bot. It connects to IRC, and then I can go on a page, talk to IRC from the node page with WebSockets, of course. And then on IRC, I can respond using the same hashtag that the bot has. It's a very simple app. The twist is I'm not actually relaying the stuff to IRC because I thought that that was very dangerous, running a load test, because they would ban me for life, etc. It's always the same problem. Like, people don't like to be nuked. So it's not connected. It has like a flag. If Nuno is on stage, don't do it. That's basically the flag. That's how the code reads. Maybe that's how I should have written it. So this did a bunch of stuff. Let's see that. It basically started gathering some stats, started running DTrace on it so that I can capture what's happening on the server in real time, and then started a server on port 80 on my remote server. My remote server is called this. This page should now work because it's on my shell. There we go. Can allow more cameras. It's good. And now I can say like, ta-da, takes a picture because WebRTC works. And now, of course, how else do you respond to the people on your page? You respond using a node REPL, of course. So reply to this guy over here saying, oh, sorry. I killed it. So I see what you mean. Let me. I killed the experiment now, Jan. Wait. Ta-da. That works. So now I have to go there again. And I can reply to the person that ta-da. Cool. So that works. That means that we can run our experiment. So here is the load test that we're going to do. It's something very similar to what we said before, except it's using this meow test is using the WebSocket type, and it's going to run versus engine IO. It doesn't do a lot, as you see, like it's during 5 seconds, 10 users a second, because just playing it safe. But in production, you don't. So then you npm run artillery, and that should start at a job ID. And there we go. We start getting like all our requests. Cool. So what should you be recording? Request latency, throughput, CPU, memory, and disk. This is the stuff that you should be recording with a script like this. It's very simple. Shell script, just go like, okay, find me all these informations. This is Solaris, probably in Linux it would be different. If your process is CPU bound, you can use flame graphs to analyze it. And that's something that right now my computer is doing on the other side, so that I have something to show you in the end. So DTrace is a dynamic tracing facility created by Brian Cantrell and others, which allows you to just look at processes while they're running in production. It's only Solaris, which sucks. Which means that once again you have to do all that dance of like creating the staging environment, running against the staging environment, or adding a Linux Solaris box, etc. It runs really well on SmartOS. So right now I'm running on Joyent to show you all this stuff. This is how you run it, how to create a flame graph. You'll find like plenty of resources. You need to install this thing called StackViz to visualize it. This is the commands you run to create the SVG that you can then look at. And then you can just like npm run experiment results. So you can see the results out of what we just did. If you're not scared, I am, because this might fail, but let's try it out. Cool, npm run results. Oh, there we go. So you see, like, here is the stats that got put in. I should have left it, shouldn't I? Anyway, the first URL that you got was just like, so GitHub as like the thing. I put it on git-gist, like with the CPU usage, etc. And then the SVG is here. So we can just go. Get the raw. That's probably a smarter way to do this. We can put it here. And now. We get something like this, which shows not only the things that got called in Node, but also the internal nodes, not only the things that got called in your code, but also the C code that got called. You can see it all up and analyze it. Of course, we did a very simple demo. We just sent messages. So this is not very meaningful, but if you are in production, this is probably the only way you have to analyze stuff in Node in production. And as you can see, I did it with a running process. I didn't have to kill anything. I just looked at it, and I have an immediate answer. So cool. So how are we doing in time, Jan? 1 minute. Okay. So this is an actual customer story. Not going to tell their names. No, I'm not. So just to see what you guys thought. So an application that this was a top 50 iPhone app, was crashing a day in production hundreds of times a day. They had very high CPU usage. They had a very high concurrency level because they were doing so well in the App Store. They had this huge 1.6 gig core dump and this tiny 36 meg heap dump on V8. So, as I said before, well, V8 is garbage collected. The core dump was like huge, but V8 was fixing everything. It was like making sure that the heap dump was very small. That is what caused the high CPU usage. What was actually happening was this. They had this kind of social network, and some guy decided to add everyone as his friend. Actually, like 10 people added everyone as a friend. So then they were using async parallel to, in parallel, going to the database and saying, for each of my friends, find me all conversations that they have. So you can use limit on async. It's great because you can limit like the size of people that are of things you are doing in concurrent. That's a good idea. Doing inbound joins with people with millions of friends, you probably want to say you can only have 500 friends. That's probably reasonable, and still tune those queries very carefully. And then you want to make sure that like Mongo is very efficient and not doing those joins. Yeah. If you do something like this, you're going to have a bad time, as Mr. Mackey would say. So more stuff that we don't have time to go into, but are very useful. Chrome Inspector is super useful when looking at node stuff. You can tie it into the inspector, look at performance, etc. You can use MDB to find leaks. And one thing that I think I've always introduced to every single customer I've had was I always insert Raygun in their system. So when there's a uncaught exception or something, I send it to Raygun, so they get a digest of bugs that they normally wouldn't find. So possible outcomes: optimize the database, optimize other endpoints, give code recommendations, blah, blah, blah. Coffee break, I don't know. No, it's our new first. Anyway, this is the important slide. If you go and like, oh, I want to refactor, don't be a fool about it, right? You have to have all these things. If you don't have unit integration, front-end tests, performance tests, security tests, and static analysis, and you're running in production a serious Node app, actually replace Node with anything, then you don't know what you're doing. Don't refactor, because the consequences will be severe. So whenever any person comes to me like, hey, Nuno, can you help me refactor the code? The answer is immediately no, unless you have all these things, or I can help you build these things. Because I'm not going to take the responsibility of JS hinting all your code only to find that it introduced something that I couldn't predict. So obey ScienceCat. That's going to help you in the long run. That's all. We didn't touch about refactoring, security, NPM, and deployment. You can come and ask me about those things. The code is there, GitHub.com, Dscape, WebRebels 14. I don't know why I did WB and not WR. That's it.
Thank you very much. Good
Thank
talk. The most pressing questions that I've got from the audience is, how did you do your slides?
That's VI. I basically Substack wrote everything that I used, so you should really ask him. I just used what Substack did.
Okay.
It's just VI and a bunch of files.
That's just a common JavaScript mantra, do what Substack
Oh, you
did
mean
for us.
the actual images? I didn't want, because I'm horrible, I'm always flipping up and down, and I know people get seasick. I've been told that before. That's something that Substack wrote called PictureTube, and I just hooked it into VI, and then I did :PT. It read the PNG and showed you as.
Okay.
Very simple.
I hope that answers that question. A question about the availability of DTrace. You mentioned Solaris, of course, and there are other implementations. What's your comment on or experience with these?
I always mix up, is it open or FreeBSD?
Free.
Fedora Indugni, which is a completely crazy engineer, crazy as in crazy good, he actually ported it to open FreeBSD. Which means you can use it in FreeBSD. But still, most cloud providers also don't offer FreeBSD, so it's really a pain. It should really be ported to Linux,
right,
so that everyone can use it.
Right, and then it's also available on Mac OS X, of course.
Yes, but not the MDB stuff and not like all this good stuff that I was running. You won't be able to run it on.
Right. Plus, you kind of don't want to run that in production.
Yeah.
Good point.
Yeah, a big problem is that you have your production machines. Normally people stick with AWS because there's the DNS and the load balancing and stuff, and then you have this machine, okay, I'm going to prepare for this machine, except you have to do your staging tests in Solaris. And that's kind of a mismatch that, makes ScienceCat unhappy.
Unhappy, yeah. Is there anything we can do if we're running on Linux?
You can convince, I don't know.
No, I mean technology.
Convince all your bosses to join together and create a port for Linux.
That's not very likely, is it?
I don't know.
Like DTrace is so good, it should have happened by now if it was any possible.
Yeah.
Well, that's all the questions I have. Thank you very much, Nuno. Thanks everyone for listening. I hope you liked it. I liked it a lot.
Thank you.
And thanks again.